Okay, let me take dispatch optimization as an example. This is a use case which is mostly relevant to markets in California, New York, Texas, a little bit in UK, but it's not yet a common need in India because we don't have an energy exchange operating. So if you look at California market, in California we have an organization called California ISO. What the ISO does is that it matches the demand with supply, and it's like a stock exchange for energy. And when it is matching the demand and supply, it is also able to tell you at what price will the trading take place. So what dispatch optimization is about is to find out the best price at which a battery should dispatch its energy into the grid so that it can fulfill the demand and it can get the best prices. Uh, so you can imagine that if you are owner of a large battery portfolio, and these are in gigawatt hours. So if you own 1 gigawatt hours of battery, you would have invested 400, $500 million. And now you want to make sure that you get a good return over investment. And for that, you want to make sure that whenever you sell energy into the grid from your batteries, it is getting the best possible price. So instead of $30, you want to make $50 in the market, just like stock trading. And what analytics does here is that it keeps the battery ready for the best prices in the market. And also, it makes sure that when the battery is actually sending the energy into the grid, it is not getting degraded. It is not losing its capacity. It is not under stress. So dispatch optimization is about making sure that the batteries health are intact, batteries perform well, they don't have a downtime, and they're charged up for the best possible time to dispatch into the market and get the maximum money from the market and improve your business ROI.
Okay. And I'm guessing predictive maintenance sort of ties into everything, right?
Absolutely, yeah. Predictive maintenance is everywhere. The key about predictive maintenance is that can you, with some degree of confidence, predict any downtime or any failure or any safety related event? And to be confident, you need to have a lot of data on which your models are trained. So it's very easy to predict a downtime, but it's very difficult to predict a downtime with high accuracy. And it's all about accuracy here. So yeah, predictive maintenance ties into all the areas of business, right after post deployment for things like safety, downtime, even degradation. But the key is how accurately can the analytics predict these events.
If you don't mind, sort of a add-on question to that last part. When it comes to, and again, that predictive maintenance would be a big part of data analytics, right?
Yeah,
Without IoT, without being able to be getting data over the air, these things wouldn't be possible. So
yeah.
when it comes to clients, fleets, OEMs, for that matter,
Mhm.
how does that part of the equation work out? From having access to the data to do that predictive maintenance, how does
Um,
that? Yeah.
it's a two-way process. The first step is to, if you think practically, the first step is to build a use case of what are the downtimes or what are the failures which are difficult to predict. So some of the downtime or some of the failures can be predicted because they are at a regular pattern, and you have some idea of if I do this, this may happen. But the step one where analytics enters is to find out what are the most difficult to predict areas of failure, and then train the model on the past instances and correlate them with all the other data points. So for example, if a downtime was caused by high voltage event, so then you have to look at the data and figure out what were the possible high voltage events which triggered this particular failure and train your model. Step two, uh, answering your question, is then being able to get this alert down to the operators, because even if you know that there is a possibility and the operators don't know, then it is useless. So sending timely alerts and notifications is one channel by which these operational improvements can be actualized. The second area that is coming up is a firmware update over the air. So if you find a systemic issue which is causing the failure, it's not an operational or a manual area of improvement. You know it's a firmware issue or it's a design issue. So especially if it is a firmware issue, using IoT Stack, you can send an update, roll out an update back to the vehicle or back to the battery system, like Tesla does, and then you can avoid these downtime in the future. Does that answer your question, or was it something different?
I think it does. It does. This whole, I mean, the maintenance side of things is two pronged, right? One is, I mean, just like your iPhone, you have issues, or no, not issues, more like software improvements that are coming from Ion Energy, and then of course you're also looking at issues happening in the field at the customer, which can be pretty unique. So those are also being tracked. Makes sense.
Yeah.